Okay, let's start. Good morning, good afternoon, good evening from TaiyangNews. We're happy you're with us today and welcome you to our webinar on larger wafer-based solar cells and modules. Probably 2 years ago, hardly any would have had this topic on his or her agenda. But things in solar can change quickly, and often actually they are not so new, even if sometimes surprising, as one would think. So I have in front of me on my computer, I cannot show it to you, still a 200 by 200 millimeter Q cells cell from actually, I don't know how many years ago, which they started once, but never made it big into the market as it was intended and as it looks from its sheer size. But nevertheless, the times have changed, and apparently now is the time for larger wafers, larger cells, and they've been quickly increasing, and that's what we want to discuss today. So we have 3 speakers with us. The first is my colleague Shravan Chunduri, our head of technology, who will give an overview on larger wafer formats for solar modules. It's a brief intro and basically a summary of what we've recently published in our advanced solar module report. Then we will have Winfried Wahl, the head of product management and chief engineer from LONGi Solar. He will talk about the value analysis of 440 watt plus bifacial modules based on M6 wafers. And with LONGi being the LONGi group being the world's largest wafer manufacturer and module manufacturer, to complement this webinar, we've invited Aiko Solar, one of the world's leading solar cell manufacturers. And here we have Vincent Lau, who's the international sales director and who will talk about the advantages of using simply larger cells in solar modules. Let's start with us. Shravan, the floor is yours.
Okay, thank you, Michael. Hello, everyone. I'm Shravan Chunduri, Technology Head at TaiyangNews. Welcome to my presentation. Today, I'm going to give a brief introduction about the PV products based on larger wafer formats. Before I go into my presentation, next slide, please. I would like to take this opportunity to provide a brief introduction of our company. TaiyangNews is an open platform. We publish reports on advanced PV technologies, and we also publish the market surveys on various production equipment and process consumables. The differentiation, the main differentiation with the TaiyangNews is our open platform. That means all the publications can be accessed for free. And Mishko is our consulting arm through which we provide services such as communication strategy development and technical research and market intelligence. So we are already on slide 3. So coming to the current subject, PV modules based on larger wafer formats has been covered as part of our report on advanced module technologies. We launched the report at REI India. We distributed free copies at the show. Nevertheless, you can download your free copy at the report section of our website. Next slide. Okay, so the module products based on larger wafer formats were already featured in our last year's report on advanced module technologies. As you can see from the graph on the right side, two module series from LG have been using 161.75 mm wafers. So one is a Neon R module series, which is a IPEC module, which has a rated power of 365, and a multi-bus bar module Neon 2 with 340 watt power output. And Jinko has also introduced its Cheetah series last year, and these modules were based on 158.75 mm wafer sizes, and this module had a power of 340 watts. So what is really more interesting is Canadian Solar, even with a multi-module, was able to join the 330 plus watt module club. The key enabler here is M6 wafer format, though these modules also feature other advanced module technologies such as MBB and the half cells. Next slide. So the next slide shows the data for this year's report. In this year's report, we raised the cutoff module power to be listed in our report for 60 cell category to 340 watts. Still, I mean, the 25 products were able to qualify this criteria. Interestingly, out of these 25, 16 are based on modules using larger wafer formats than the standard M2 wafers. So this is also indicated with a different color. What you see here is which are all the module products which are in red color. They are using modules based on larger wafer formats, and the orange ones, we don't know. Some are definitely not using larger wafer formats, but some companies, they haven't told us what's the wafer size. So that is why, though it is not a change in wafer, the larger wafer format is a change in a wafer size, but still we consider that this technology is a technology to improve the module power. Next slide, please. And the most interesting aspect of the larger wafer formats is very minimal in effort. So this is also the reason why several companies are taking this path. Actually, when looking at the wafer sizes, 156 mm was a standard for nearly a decade. Then world's leading wafer manufacturer LONGi has commercialized M2 wafer format in 2017, and it became a standard in 2018. Now, actually, there is a race to increase the wafer size. It is really the talk of Solar Town. It is M6, so which is 166.75. Canadian Solar was the first to introduce M6 size for multicrystalline, but now LONGi is also highly promoting M6 wafer formats. The advantage with M6 is it has 12% higher surface area compared to M2. That means there will be a proportional power gain at the module level when switching from M2 to M6. So it is also actually not stopping at M6. Another wafer maker, Zhonghuan, has announced in August that they are going to introduce M10 and M12, which are up to 210 mm side length. However, according to our research, wafer formats up to M4 can be processed without any change, but M6 requires some change in processing tools, at least in handling tools, if not completely. So here I would like to end my presentation, this brief introduction. Winfried and Vincent will provide more insight into the value proposition of large wafer formats at module and cell levels. Thank you for your attention.
Thanks, Ravan. Okay, so then we continue with Winfried, then comes Vincent, and that will be followed then by a Q&A.
Okay.
Winfried, floor is yours. think you have to unmute yourself, Winfried, or Min, can you unmute? Oh.
Okay, should work now. Yeah, good afternoon, good evening, good morning, everybody. What I prepared as well as Shravan introduced is a analysis in a bit more depth on the what does it mean bigger wafers on module level. Before going into that, please allow me to give a very brief introduction in our company. LONGi, for those of you who are not knowing us still, it's been founded in 2020, and the main business we did at the early days was doing the ingoting, later the wafer. And since 2014-15, we are in the PV module business, which is under LONGi Solar, which is as well the business unit or the department I belong to. And last but not least, there as well exists LONGi Energy, who is building complete power plants. This business model is limited to China and some very limited areas in Africa. So the main thing has been already introduced. We are the largest producer for mono wafers. So we accounted in 2018 for 40% of the total global mono wafer capacity. And that means this year in 2019, we are at 36 gigawatt wafer capacity, roughly 16 gigawatt of module capacity. Next year, the numbers are going to be 50 for wafers and 25 for modules, with new factories going live. And in 2021, even more, we keep on with our expansion strategy. There will be 65 gigawatt of mono wafer capacity online and available, and roughly 30% of the 65, about 30 gigawatt is expected to be our module capacity at this stage. So we are really a big player. Maybe one of our big advantages is that we have from day one been focused on mono and switched to mono-PERC as maybe one of the first ones completely. So there's so we have been always focusing on a high end of products, but still keeping in mind that our main goal is the lowest cost of electricity. So we are not doing technology for fun to have super duper front nameplates. At the end, it has to be affordable and lead to low electricity prices. This slide shows a comparison between M2, M4, and M6 wafers, where you see the ingots diameters 216, 217, and 229. As it has been the market standard for quite a while. M2 has been dominating for almost a decade. Some of the market players have moved to a format M4, which is slightly bigger, has a slight area increase. You can see it, a 5.7% increase. And then on the top right-hand side, you see the products you can do out of an larger ingot, either do M6 cells with still the corners, or go with a full square approach, which is the format which has been introduced as well before. The biggest gain, and as if you just imagine that the technology applied would be the same for all those wafers, then the 2.21% in surface, you can more or less directly convert into module power, and that's what I did on the lower part of the presentation. If you build a product today on the same efficiency of cell based on M2, then the reference would be something like 392 watt peak. If you go with 158.75 full square wafer, then you would reach up roughly at 404 watt peak. If you go with a bigger wafer, M4 format, you would end up with 414. And if you target for M6, that's what we are actually doing in our product family, then you would go to 440, which is an increase of 12.21% if you would apply exactly the same technology. Let me, in the next slide, show you a graphic of our product history. I've been summarizing the HIMO 1 up to HIMO 4 product range. HIMO, all of them are based on mono PERC technology. And you can see the HIMO 1 and HIMO 2, they have been based on full cell formats, monofacial and bifacial. They're going to be phased out during this year. And even the HIMO 3, which is based on M2 half-cut format, which actually was a full product family, they will be superseded peak based on the 60 cell format and up to 445 watt peak on the 72 or precisely 2 times 72 format. And we have just started in mass production in Q3. So since September, we are producing on large scale. Before there were a bunch of test runs, and the feedback from the customers is well, they like it very much because of the reasons I'm going to tell you in a few slides from now. The third generation, so the products which we had right now, they were based on M2 wafers. There's a full product range, 62, 72 cells, monofacial and bifacial. And it depends on the speed of your connection. You would now see, switching to the next slide, when it goes to HIMO 4, all of those products have slightly become bigger because they are using the M6 wafers. So that means in width, it is roughly 6 centimeter more width, 6 times the 10 millimeters of the bigger wafers. The cells used in this product family, they are as well half cut. They are upgraded PERC technology, mono PERC technology, with efficiency up to 22.5% based on a 6 bus bar design. And as I said, the plan from our side is to first of all introduce and complete the ramp up of the production of the M6 based products, the HIMO 4 family, and have some time of parallel production with the M2 based products, and then try to switch completely to the bigger format as cost advantages and power advantages for our customers. If we go to combine the products with bifacial, so the cells M6 based exist, as I said, as well in bifacial design. I'm showing you here a slide to explain the additional gain, what you can get using a bifacial cell compared to a monofacial cell. And this slide shows the test partner companies, the test sites we are using all over the world, starting in the US, where we had between 8 and roughly 10% additional energy produced on some gravel surface. But you can see there would be still some way to optimize that mounting structure to get to slightly higher numbers. In Middle East, in Saudi Arabia, on sand, we had 11%. In India, when the gravel has been white or even this very clean and very high reflecting material, we could reach up to 20%. And that has been more or less confirmed as well with on our test site in China, that if you have a highly reflecting ground, but with white coating, with a white painted concrete or something similar, the bifacial cells could give you 20% extra energy from the rear side. Just keep in mind, this is R&D and test sites which have high maintenance, where technical guys are running all day around and take care. In real installations, I would say if you are able to achieve 8 to 15% extra energy without doing too much of to keep the site in shape and keeps the ground white and reflecting. That is very realistic. And the combination of mono-PERC and bifacial, that is really used in a lot of installations all over the world because of the lower LCOE. So the additional energy yield that leads to the fact that the price of electricity has been going down. I've pointed 3 installations in the United States and Mexico, which all of them are above 200 megawatt of site, all of them in bifacial. We had a 380 megawatt site in Egypt, which is live, and even in Germany, a smaller installation of the 750 kW, where the customer reports something like 10% extra yield based on grassland. And I just wanted to use this slide to tell you that, first of all, bifacial is really becoming the trend because of the extra additional energy produced, and as a matter of fact, the lower electricity cost or lower generation cost of electricity. And most of the installations are in quite sunny areas. If I compare now a LONGi bifacial system based on M2 versus M6, and I've just taken a peer-to-peer comparison of our existing products to underline why we are moving to the bigger formats, is comparing 390 based on M2, a product from the HIMO 3 family, compared to HIMO 4 440 watt peak. You would use 11% less modules, so you can reach the same park size by less modules to be installed, which for sure results in savings on mounting cost. In this calculation, this is roughly 6%. You save on pile foundation, you save on combiner boxes, on cables, just because the number of modules is reduced you would need for the installation. And due to the fact that the tables would be then equipped with bigger tables, there's as well some little saving on land occupation, which is not relevant in areas where land is more or less for free, in desert areas where you don't need to care for land. But keep in mind, for highly populated areas like in Europe, land has a price, and then saving on land is as well an advantage. If we go to the next slide, and I do the same comparison based on a calculation made for Cologne in Germany, assuming that the park would produce 1080 kilowatt hours per kilowatt peak, which is very conservative. It should be normally a bit higher, keeping in mind that as well this is based on bifacial. The LCOE would go down by a tenth of a cent on this calculation. The parameters you can see on the bottom left. But let me underline at this point as well that the calculation has been made very conservatively with very defensive numbers. So the yield should be higher, and some costs in this model should be lower. Maybe you can do the calculation based on your experience and on your partners. So this is comparing the HIMO 3 M2 based versus HIMO 4 440. And the next slide I'm going to show you is if we go into areas where the irradiation is higher. The black dots are on points calculation made with 1000 kilowatt hours per kilowatt peak installed as a calculation base. The yellow points are for 1500. So if you go direction of Spain, Italy, or those countries, and if you go red really into the Sunbelt areas with where you can reach 2000 kilowatt hours per kilowatt peak, then the numbers are around 2 cents per kilowatt hour produced. Again, this is very conservative calculation. We do not want to forbid anybody to earn money, but as well, there is a huge benefit when you go from monofacial to bifacial. Last but not least, is another graph I'm always using. In the nameplate power of a module is one thing. How much energy it generates at the end of the day is sometimes the other thing. Here we have been, in the past 3 years, winner of the TÜV Rheinland All Quality Matters Award, which has been performed in 2017 and 2018 on a simulation base. So modules have been tested and data taken from a lab in TÜV Rheinland group, and then they did the simulation with PV-Assist. And in the last year, the award which has been passed in this year, it was outdoor power generation. The number one module you see on the right-hand side by PV Magazine test is a bifacial mono-PERC module of the HIMO 1 generation, the same as the item 4 and 5. They are as well members of the, the bifacial is HIMO 2, the number 4 and 5 was HIMO first generation products. So they're still new, just a few years ago. Things are moving quicker, as Michael introduced, and we expect to have results in the future, similar results with the HIMO 3 and HIMO 4 series. Let me conclude this short speech with some highlights, explaining why we are moving in this direction and why as well it is beneficial for our customers to move to bigger wafers. Is the step from M2 to M6, I told you, has already 12.2% higher cell area, which if I compare our products, resulted into 15% more power per module, because there have been some other improvements made on the HIMO 4 series, like increase of busbar numbers. The result is lower BOS cost, and in regards to the system design, there's no disadvantage. The modules have the same VOC, so you can build the same string length like you could build before. The only thing you need to be a little bit careful of, the current is keep on increasing, so that your inverter can manage the higher currents. With bifacial versions, which are built out of double glass construction, we expect in grassland 8% additional gain, up to 15% in normal sandy areas. The warranty duration is 5 years longer, 30 years compared to 25 years. And another point which you should note is that the maximum annual degradation, which is covered by our warranty, is 0.45% per year. So there's hardly any aging in this mono-PERC products. So if you ask us, the lowest LCOE solution today, we say it is mono-PERC, it is bifacial, and is M6 based, which is in our portfolio called HIMO 4 series. Thank you very much. I'm available at the end of the presentation for questions. Thank you.
Thanks, Winfried, for this very comprehensive and nice presentation on large scale modules with large scale cells and wafers. We are now coming to the final presentation from Vincent Lau from Aiko Solar, who will give us some background why one of the world's leading cell manufacturers is moving to larger cells. You are invited to already ask questions on the control panel. I will collect the questions, and after Vincent's presentation, the panelists will then be available to answer that. But so that I have a chance to read through them, it would be nice if you could already start writing some of them. Thanks so much. Vincent, the floor is yours.
Okay, thank you. So I just open up my presentation, and you can see we are Aiko Solar, and let me introduce Aiko Solar a little bit, and later on we go to the product introduction and explain how the larger size cell.
Vincent, wait, we are not seeing your screen.
Okay, hold on just a second. So can you see my screen?
Yes, thanks.
Okay, great. Okay, yeah. Let me restart it again. This is Aiko Solar. My name is Vincent, and we was founded in year 2009. As everybody did in the past time, we start from the polycrystalline in year 2009, and in year 2016 and the beginning of 17, we decided we needed to produce the mono PERC. So we started our production. Everything's in China, in EU, and until today, we already our PERC cell efficiency already break to 2.5% and convert it to module power that is 415 watt modules, and the output is provided by 158.75 millimeter cells and a full square mono cell that's called G1. And in Q3 this year, and just happened in September, we launched the first, actually it's not pilot run anymore, it's a mass production line for 166 millimeters cells. And also we are the pioneer for bifacial cell measurement and binding for the real site. And until this quarter, beginning of this quarter, middle of this quarter, our bifacial PERC shipment, we hit 3.0 gigawatts. And also for PERC shipment, monosite, there will be 8.7 gigawatts. And we won the 21st China Patent Excellency Award. So this is our 3 different factories. So let me go to the page 3. At this moment, our plan is to build 13 gigawatts capacity in total. We start from Guangdong, the bottom side here, that's 1.6 gigawatts. And in EU, we have 2 different phases. That's phase 1 and phase 2. And in Tianjin, there's already being produced. That's 3.8 gigawatts. And for those factories added together, we have 13 gigawatts capacity. And half of land, we can produce 166 and above. So because we believe the larger size of cell will be the trend for the coming futures. Okay, so let me go to the page 4. So we put the milestone here. In the past, everybody know we use a small size of the wafers, and so it is the cell. So with the 125, and we started from years 2000, the wafer started from year 2002, and until 2014, the big size is as N2, 150.675, and from year 2018-19, we start to promote the 158.75 and M4. So we call that 4.0 eras because of the M4. And from this quarter, we would like to set the 4.5 era start. And for the future, there will be 5.0 eras because there will be the market and world for 166 and above. That's a larger size to the market, and the response we receive from the customers, and also no matter the Chinese customers and or international customers, they are all welcome for such development and also larger size, because the larger size can provide more powers, make them more competitive in the market. So you can see the it just LONGi introduced earlier. They come from the different size of the ingot. So you can see the three size here. They're all coming from 211 millimeters. The M2 Shudo and the G1 Shudo, and also the M4 Shudos. Each one is a little bit bigger than the previous one. It means the more power and can be provided, and the module size can produce more powerful module than others. So the cell size development is going on, and what we know from the customers is they are modifying their lines. They want to retrofit their production line for larger size, because that is the way they can get more power from the module side, and also reduce the BOM cost for the EPC. Okay, for the page 6, that's 2 to 3 millimeters ingot. Again, there will be three sides of the wafer, and also the cell can be coming from this ingot. There's a G1 and M4 Plus, also the M6. So the M4, actually you can have a two different size. It's called standard M4. The other one is called M4 Plus. They come from different ingot. Still, the M4 Plus a little bit bigger than the M4, so it can have like a 3 to 5 watts more powers than the M4 standards. This size is also being taken by module makers. It's not a big volume yet, but we believe there will be the trend for the international module makers, because that's easier to get something bigger than and like make them different from the competitors. So this size shows, this slide shows the wafer roadmap and also our cell roadmap. So from the left hand side, the M2, until the right hand side, the M6, we put it in two different groups. One is the blue one, the other one is red one. You can see the G1 is 2.38% larger than the M2, and we jumped into the M4 Plus, 0.89% larger than M2. And for the big one, the M6 Shudo square, that's a 12.21% large M2. And these products are currently being produced and shipped to the module maker right now. And it seems in the coming 2 years, the size, the cell size, will be very complicated, because you can come here, there's 6 different wafer size and also the cell size. So each time we produce different size, we have to make sure the efficiency and also the quantity they need, and that will be a very heavy works on our production line, because each time we have to switch the production plan, so change the screen and adjust and also modify the production parameters a little bit, so in order to produce different size to meet the customer's demand. Okay, let me go to the page A. We put also 2 different groups. One is the cell efficiency and also size. On the right hand side, you can see that is our forecast plus the response from our customers. So on the left-hand side, you can see the M2 powers. The higher the green one will be for 5 bus bar. The green one will be 5.35 watts. And then you go to the red one, there will be 12 bus bar with M2 size. Actually, you can see no difference for the between 9 and the 12 bus bar. But if you go to the M4 and the M6, you can see the gap is getting bigger, and it started. For the M4, the 9 bus bar is 5.82 watts. For the 12 bus bar, it will be 5.95 watts. For the M6, the 166, the gap even bigger. So we convert it to modules. You can see the 166 millimeters. That from the bottom, there will be 430 watts to the largest one, there will be 450 watts per modules. So it's incredible height, and you can see from here, it's very advantage of multi-bus bar solution on 166 size cells. So with the larger size of wafer, we put it into the produce it into cell, and we also use some different technology in the production way to increase its power. One of them is multi-bus bar. In the market right now, the demand is from 5, 9, and the 12 bus bar. They all have a different support from the module makers, and not just that. Just as LONGi just mentioned, the bifacial. It is also one of the way to increase the output, and also not for the module output, and also the power generation from the engine. So let me go to the page 9. So 166 millimeters, if we put it in the modules, that is 65 watts higher than M2 modules, and also it's 35 watts higher than G1 modules, and the conversion rate reached 20.27%. So you can see the table here. We collect the data from our customers and also our partners. And from the left-hand side, that's M2 mono. That's baseline. Efficiency is 22.5, the highest one. And on the right-hand side, you have 166 pseudo mono perk. And the highest output we forecast, it's not forecast, it's real output, is to 450 watts. And the module rate is 20.27%. By using such high output modules, the cost is reduced a lot, and is so welcome for the ground mount power station. Okay. Let me go to the page 10. You can see the right-hand side, the upside there, the source from PV-Info Link. PV-Info Link forecasts the market shares for each different size. From year 2020, the G1 would take the main strength in the market, and the year 2021 and the year 2022, and they will hit almost 80%. And in year 2023, the G1 to start to reduce size above 160. We take also the market share, the major market shares. However, we have a more optimistic thinking, and also we think about a more positive. You can see based on our forecast and also the response from the customers and our partners. It started from year 2020. The size above 166 will start to pick up, and until year 2023, there will be more than the M4, the M6 with more than 50% in the market. So we have a more positive way to think about the development. So the page 11 again, that's also the major way to increase the power generation. You can see there's two different charts. One is for the cell, while the other one is for the modules. The baseline, the base forecast is from ITRPV. They are thinking the 60% of the cell market will be taken by the bifacials, and for the module it will be 50%. But however, we have a more positive thinking. In year 2029, the bifacial cell will take almost 90%, and for the module they will take almost 80%. So bifacial is already the mainstream in the market, and it is happening. And Aiko Solar is probably the only one and the first one to do the classification for the rear side and also the front side. So there's three advantages here. No handleable to implement bifacial, and also at the cell end, no additional investment in online testing, and the bifacial efficient classification, EL selection, and also bifacial color classification can be done simultaneously. And why we want to do the classification for both sides. So for the front side, everybody can do it. That's not a problem. But for the rear side, you can see that here, if we don't do the classification and the binning on the, if the low efficiency cells produced and put on the modules, you can see the hotspot layers, because all the current and the power go to the weak one, and you will see the left hand side, there's a hotspot. If that occurred and stay there for longer time, the module life cycle will be totally reduced a lot, and there's also caused the problem on the power generation too. So there's something we shipped out with the bifacial. We also do the colors for the color classification. It's ABC gray, ABC colors, and also the front side efficiency and the rear side efficiency. So that can maximize front efficiency and also consistent back efficiency. So here again, this we show you the cell size we have produced now. Each of them has a different combination. So the larger size is definitely a trend for the future, and it's happening. But at this moment, it's also heavy work on our sales as sales makers. But it is our way and our thinking, and our we would like to, and something we would like to promote it, because they can help everybody can be very competitive in the market. Okay, that will be the end of my presentation, and you're welcome to send me the question. I will try my best to answer you. Thank you.
Thanks, Vincent, sharing your views as a cell maker. So let's have a Q&A with the panel. We have 10 minutes, so I ask everyone really to answer very briefly. We have a lot of questions, so let's try to answer as many as possible. Maybe this one first. I think this is an interesting one. So what would be the impact of larger wafers on module sizes? Because what we're seeing, we have that also in our report, that the sizes are actually now very, very different. Do you think, Winfried, Vincent, that there will be at some point again a module standard, which makes it easier for mounting equipment makers and also EPCs to select and adapt to their planning?
Yeah, it's a very good question, because at the moment we are something in between, or somehow on a travel that different companies have taken different approaches. LONGi has been going from M2 directly to M6 without any intermediate step, and at the moment more and more players are following us on M6. The module sizes will become very much similar again. Today, as we have all those different formats in the market where everybody tried to optimize a little bit, it's a huge range that, for example, the width will be between 990 with the traditional design up to 1050 in width. So that's something like 6 centimeter in difference. It depends on how quick the market moves.
Okay. Although obviously we also don't know, because Zhongguan just also Vincent has shown that also even larger formats which are up to 210 millimeters. So do you think 166 is where it ends for the moment, or will we see soon larger wafers? And actually the question is also, how large can it go? Maybe to both of you, Winfried, Vincent.
Maybe quick. LONGi believes M6 is the choice now, but I don't know what's going to be in 2 to 5 years. Depends on equipment and other things as well.
Yes, I agree this point. 166 is the best choice right now. Something bigger than that, we have to think about it. Yeah, because it require a new investment and also new production technologies.
Okay. In terms of when we talk about general going to larger cells wafer sizes, how does that impact mechanical durability, in particular micro cracks?
Yes, that will be the issue we needed to overcome right now, the micro crack and also the weapage on the production line. But all I can say is it's getting fixed, and these issues are being removed right now.
Okay. We see on the one hand, so of course PERC has become the new standard, but on the other hand, there's also trends to even higher efficiency or other advanced cell technologies like passivated contacts TOPCon or heterojunction. So regarding larger wafers, will that also apply to N-type wafers in the same manner? So question is, will M6 be also offered in terms of N-type wafers or cells?
Why not? I mean, we have a more or less three-dimensional optimization to do. One is, or the result should be the product which delivers the lowest cost of electricity, and then the one dimension is the size, as we discussed today very intensively, and the other dimension is the technology which can be applied. What we learned so far is, what we experienced so far is that a lot of the technologies you just mentioned are giving a higher cost disadvantage. So the industry decides now to do the first the change of size and think about the technology upgrades which are still possible at a later stage. But yes, to your answer to your question, I think the technology is not depending on the wafer size.
Yes, there are many new technology, like you mentioned, the TOPCon and also the HJT, also the N-type. So we still have a lot of things and a lot of subject needed to study. Yes, definitely new technology and high efficiency that we welcome in the market.
Here, that's a question from an EPC. So with M6 wafers, 72 cell modules becoming considerably bigger. So how does LONGi mitigate wind snow load issues, especially for modules installed on single axis trackers using central torque tubes and relatively short mounting brackets?
Yeah, the mechanical loads, that's one thing which needs to be addressed. One thing is the design of the frame, which is giving most of the stability to the products. There's a difference between the HIMO 3 and HIMO 4 series in regards to the frame design to mitigate this thing that we can offer or survive in the same mechanical strengths. That is true, but honestly, for the central mount, I think the background is about next tracker. It's not so much used in Europe, and so I do not have really experience on those single axis tracker things with the central mount. Okay. I have to admit. But maybe that person can send me an email. I think the email is in the contacts.
Yeah. Okay, I think that is there an you showed, Winfried, that also of course there's a lot of costs going down. You need basically less modules, you need less land. Well, but of course the modules again are getting larger. So does it mean actually that you need more people to install those modules at some point? So the question is there an increase of labor actually with the trend towards larger modules, because it's not so easy to lift them?
Yeah, it's a good question. It depends on the application. I mean, we have rooftop installation on tilted roofs, we have flat roof, and we have the ground mount installations. I think the easiest is the ground mount installation with a huge number of modules to be installed. There's in most of the places there is tools there, and typically 2 people are lifting the modules on the tracker, on the mounting structure. For the smaller roofs, yeah, the increase in weight is a consequence, and not everybody will like it. So it could be that there are some disadvantages in some residential areas where you would need a second person to lift the module on the roof.
With the wafer size enlarging, so what does it mean for thickness? Because I think recently we have seen, after a long time, actually also wafers becoming thinner. So, but with the trends towards larger wafers, what does it mean? What will be the thickness for 166 and potentially larger formats?
Maybe I keep it short for LONGi. We have the same, this 200 micron thickness. So there's no change. The challenge was to put the machinery in place to not get a higher scrap rate than before with the smaller wafers, but the thickness is identical.
Okay. Maybe to Vincent. So what can you exactly say what you have changed in your equipment for the line that's now processing the M6 wafers?
Yes, our line is designed to be switchable. So right now, our line can be switched for production from M2 and also up to the M6. There's some tooling, the holder and also the conveyors on the production line that needed to be changed if changing the production from M2 to M6. So the main machine will be the same, but the transportation tools will be needed to change, and the holders.
Okay.
Right.
And for, if you look at older equipment, actually, I think you said that's a newer line, but if you look at older line and you want to refurbish them, what needs to be done then there? Let's say if you have a line which is 3 years old.
the size is very important. I'm not sure if that, for example, 3 years old, the machine can be retrofit or modify it to M6. I'm not sure about it, but all our equipment is new orders. And before we purchase those machines, we already talked to the equipment those, so they follow our order to produce that. Right, so not sure if we can modify the older line.
Yeah, Shravan, what did you hear from equipment manufacturers when you basically did your surveys recently on M6?
Yeah, as I said earlier in the presentation, so what I heard was up to M4 there is no change required, but moving to M6 probably some handling tools might have to be optimized, and then it also depends on whether the process and the particular equipment is inline, batch, or you know, these things also play a role, and also the age of the equipment. So how new is the equipment, and how susceptible is the equipment for the changes in the handling automation. So I think there is no simple answer for this, especially for the old equipment. So this varies from customer to customer, and also from each equipment used at particular process station has to be dealt differently.
Okay, thanks. I think the hour is over. Probably everyone or many people have to head to different meetings. So as Vincent said, you're all invited to write to the presenters, to Shravan, to Vincent, to Winfried, your questions, and they will be happy to answer that. Just bear with us one more moment. So next from us, if you're this week in Shanghai and are visiting CSPV, which is China's largest solar scientific conference, we from TaiyangNews are organizing a session there that will be on the 22nd of November. And we have, the session is on passivated contact. So it's about European production technology for processing passivated contact solar cells. I believe it's the only English-speaking session at CSPV. If you're there and interested in European manufacturing equipment for TOPCon cells, you're invited to join us. And finally, we would like to draw your attention to our next webinar, which will be on early December, and it will be on bifacial cell technology. We will give a short glimpse also already on our report, which will be published in the middle of that month. Thank you so much for joining us, and hope to have you back with us soon. Thanks, and have a great day, a great evening. Bye-bye.